I was scrolling through a few past papers, and I found this trig question right here which looked quite interesting, so I thought, why not give it a shot? Alright, so, step 1. Show that the equation 6 cos squared theta equals tan theta cos theta plus 4 can be expressed in the form 6 sine squared theta plus sine theta minus 2 equals 0. So what do we immediately realise? We see they want it in the form sine theta, and we have an equation written with cos thetas. So what we can do to transform the equation is, first of all, let's just write down the identities we know. So cos squared theta equals 1 minus sine squared theta, and tan theta equals sine theta over cos theta, which means we can rewrite the top equation as 6 times 1 minus sine squared theta equals sine theta over cos theta times cos theta plus 4. And let's just expand that out quickly. 6 minus 6 sine squared theta equals sine theta plus 4. 6 sine squared theta plus sine theta minus 2 equals 0, which is the form that we need it to be in. Okay, now part 2. Alright, let's move on to part B. So, solve the inequality 6 cos squared theta is greater than tan theta cos theta plus 4 for this range. So what we've already done is that we have rearranged this into a quadratic in sine theta. So all we need to do now is solve that quadratic and look for the ranges we want. We can rewrite this rearranged form as an inequality. 6 sine squared theta plus sine theta minus 2, and here's the important bit, you need to get the inequality sign the right way around. It's actually less than 0. Because when we rearranged this into this form, we brought everything over to the right hand side. So we would actually basically just have the entire equation on the right hand side, and the inequality sign would be facing the other way. That's why we convert it to a less than 0 here. Okay, now, this bit's simple, it's just a disguised quadratic. Let's say sine theta equals s to make it simple. 3s minus 2 times 2s plus 1 is less than 0. So let's just sketch out our quadratic quickly. It has a positive s squared coefficient, so it needs to be u-shaped, and the y-intercept is minus 2, so it'll look something like that. We're looking for less than 0, so we're looking for the bowl in between. So, our critical values are s equals 2/3 and s equals minus 1/2. So we want to find minus 1/2 is less than sine theta is less than 2/3. Now, how do we do that? We need to do a quick sketch of the sine graph. So, there we are. That's a very poor sketch, but it'll work. Now, let's draw on our y equals 2/3, which is about there, and our y equals minus 1/2. Let me just move that down a bit, that's a bit confusing. Okay, we want minus 1/2 is less than sine theta is less than 2/3, right? So we want whichever parts of this sine graph are between these two lines, which would be this part here, and this part here. The way we need to do that is we need to figure out what these points actually are. So let's work out the 2/3 bit first, the upper bit. Sine inverse of 2/3 is 41.8. And the next point where sine theta equals 2/3 is 180 minus that, which is 138.2. And now let's do the minus 1/2 bit. So sine inverse of minus 1/2 is 210. And the next point where sine is minus 1/2 would be 540 minus this, which is 330 degrees. So now we have the coordinates of all of these points. Remember, we want these bits, the bits in between the lines. So this bit is going to be theta is less than 41.8. Let's write that there. Theta is less than 41.8. This bit is going to be 138.2 is less than theta is less than 210. And this bit here is going to be theta is greater than 330. And that is all you need to do for that problem. That was a quick taster of how we teach Enabler tuition. We make sure that you understand the entire process, not just memorizing procedures, but actually understanding what you're doing. If you want to book a free 30-minute session, head over to nablertuition.com or email us at contact@nablertuition.com. Thank you for watching.